Hello students, today we're gonna talk about atomic structure. This one is part 1, so in the next meeting will be part 2. You may check this about atomic structure in your chemistry book, page 75. Introduction of atoms. Before we talk about atoms, let's recall what you have learned in the previous semester in the last level. You have learned about the element, right? Do you remember what element is? Yeah, element is a substance that cannot be broken down into two or more simpler substances by both chemical and physical processes. Elements are composed of extremely small particles called atoms. Atoms are made up of protons, neutrons, and electrons, which are collectively known as subatomic particles. Let's take a look at this picture, everyone. We can see electrons here, the small things here, around the nucleus. This one is the nucleus. And then inside the nucleus, you can see the neutrons and protons. Okay, let's discuss one by one. First, let's discuss about electrons. As you can see, electrons are found outside the nucleus. It is negatively charged. Look at this. Outside the nucleus. It is negatively charged, so it has the symbol of E-. And then protons found in the nucleus. This one, proton. For neutral atom, positive charge is equal in magnitude to the electron's negative charge. So in neutral atom, the number of protons are equal to the number of electrons. Last subatomic particles, neutrons. You can find neutrons in the nucleus. It has no charge and virtually same mass as proton here. So we can conclude, for what we have discussed, protons and neutrons are tightly packed together within a nucleus in the center of an atom, whereas electrons move rapidly around the nucleus. Now, let's talk about the relative charge, relative mass, and the symbol of each type of subatomic particles. First, let's talk about relative charge. The relative charge of proton is +1. It means positive 1, while neutron has a relative charge of 0. It means neutral. Electrons has a relative charge of -1. It means negative 1. Now, let's talk about the relative mass of each subatomic particles. Proton has a relative mass of 1, while neutron has a relative mass of 1. Electron has a relative mass of 1 per 1840. That means electron has the smallest mass compared to the other subatomic particles. Proton is represented by the symbol P. Neutron is represented by the symbol N. And electron is represented by the symbol E. So we can conclude, nucleus is the central core, positively charged, contain most of the atom's mass. Electrons, very light, negatively charged, exist in the region around the nucleus. Now, let's discuss about another topics. Atoms of different elements have different numbers of protons. Let us see figure 5.2 shows the atomic structures of helium, lithium, and beryllium. Look at that, everyone. First, we have atom helium, He, lithium, Li, and beryllium, Be. Look at this. The number of protons of each atom are different. Helium contains 2 protons, while lithium contains 3 protons, and beryllium contains 4 protons. You can check this in your textbook, page 77. The number of electrons in an atom is the same as the number of protons. Therefore, the negative charges cancel out the positive charges. An atom is electrically neutral. This one is like what we have discussed in the previous slide. Now, I will show you how we can check the number of protons in periodic table. Okay, everyone, I'm sure that you have learned this periodic table in the previous level. We have discussed periodic table in chapter elements, compounds, and mixture. Okay, so in here, we can see group 1, group 2, etc. How can we check the number of protons? Look at this. This one is the element of hydrogen. It has the number of proton 1. And then helium here, it has the number of proton 2. Lithium has a number of proton 3. Beryllium has the number of proton 4. Boron has the number of proton 5, etc. Can you see that? Can you see the pattern in here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, etc. Okay, so numbers above the symbol of element represent the proton number. Chemical symbols. Here I have symbols X, A, Z. A is written in superscript, Z is written in subscript. Both A and Z are written on the left of the chemical symbol. It means the X is the symbol of the element or chemical symbol of the element. Z is the atomic number or number of protons. A is the mass number or the number of protons and neutrons. Let's do this. Given that helium atom has 2 protons and 2 electrons, what are the total relative positive and negative charges? Total relative positive and negative charges. Do you remember what proton is? And what is electron? Yeah, so the answer is plus 2 and minus 2. Plus 2 from the number of protons, 2 protons, and minus 2 for the number of electrons, 2 electrons. Now, what is the overall charge of the helium atom? Look at the number of protons and electrons. Are they same? Yeah, so the answer is 0. It means the helium atom in this case is neutral atom. Good job. The number of protons and electrons in an atom of any elements is the same and hence an atom is electrically neutral. So, I will show you how it works. Here is the simulation platform that I will give you the link so you can access later. I will show you how the atom can be neutral atom. First, let's give it a check. Okay. So, if I add 1 proton in here, it becomes hydrogen atom. But in here, it shows plus ion. It means the atom is not neutral. How can I make the atom neutral? Yeah, by adding the electron. Since the number of proton is 1, so I need to add one more electron. Let's check this. Yeah, now the electron is the same as the number of proton. Okay, what if I add one more proton? Yeah, it becomes helium. And also, it is ion, unstable. How to make it stable? Let's add one neutron. Okay, it becomes stable. But the atom is still ion. It's not a neutral atom. So we need to add one more electron. Okay, now the number of electrons are the same with the number of protons. Do you get that? Okay, let's add one more proton. Now let's go back to the PowerPoint presentation. We're gonna talk about proton number. Number of protons in an atom is also called atomic number. Proton number is equivalent to the number of electrons in an atom since the atom is neutral atom. Okay, so we can see here in the periodic table, numbers above the symbol of element represent proton number, same as before, yeah? Now everyone, please answer this question. Do any two elements have the same proton number? What is your answer? Okay, the answer is no. No, yeah? No, they don't. Okay, good. Now, let's move to nuclear number. So, nuclear number is the total number of protons and neutrons. The nuclear number is also called the mass number. Suppose that an atom has 10 protons and 11 neutrons. So, the nuclear number becomes 21. 10 plus 11, 21. Let's take another example in this simulation. If I have 3 protons, 3 electrons, I want to make it stable and neutral atom. I want to add some neutrons here. Okay, let's check the mass number. Okay, 6. The mass number is 6, or nuclear number is 6. Okay, how can you get that? So in here, it has 3 protons and 3 neutrons. It becomes 6. Do you get that? I'm sure you can answer this. How many neutrons does a hydrogen atom have? This one is the neutral atom. How many neutrons? Yeah, it is 0. It is 0 because 1 in here represents the number of proton or atomic number and also the number of electrons since this atom is neutral, and the 1 in here, the superscript 1, represents the mass number. Okay, while mass number equals the number of protons plus the number of neutrons. If the total is 1, while the proton number is 1, so the neutrons must be 1 minus 1 equals 0. In the previous simulation, you can see the term ions. Loss or gain of an electron makes an atom into an ion. Losing an electron makes a positive ion. Losing an electron makes a positive ion. Gaining an electron makes a negative ion. So, we can conclude when an atom has more electrons, it becomes negatively charged. When an atom loses its electron, it becomes positively charged, positive ion. Let's see the simulation again. I want to make this atom becomes negatively charged or negative ion. So, I have to make the number of electron is greater than the number of proton. See? It becomes negative ion. What if I add one more proton? It becomes neutral again, but unstable. So I want to add one neutron, another neutron. Okay, it becomes stable. If I want to make it a positive ion, I need to add more proton. See, it becomes positive ion. That's all for atomic structure part 1. I'll see you on the next part, everyone. Bye-bye.